Hello, hi, welcome to my channel EDHAKAR'S Physics Academy. So అందరికి ఉగాది శుభాకాంక్షలు. హ్యాపీ ఉగాది 2026. సో మీకు మీ కుటుంబ సభ్యులకు విశ్వ వసు నామ సంవత్సర ఉగాది శుభాకాంక్షలు. సో ఎవ్రీ ఇయర్ వి ఆర్ సెలబ్రేటింగ్ ఉగాది ఫెస్టివల్. సో ఎందుకంటే మనకు ఆల్రెడీ తెలిసిందే, ఇంతకుముందు పూర్వం ఒక రాక్షసుడు బ్రహ్మ దగ్గర పత్రాలు తీసుకెళ్లడం వల్ల సో విష్ణువు మళ్ళీ మత్స్యావతారం ఎత్తి తర్వాత ఆ పత్రాలు మళ్ళీ రిటర్న్ చేసి వచ్చి మళ్ళీ యుగాంతమైన తర్వాత మళ్ళీ యుగం స్టార్ట్ అవ్వడాన్ని ఉగాది ఫెస్టివల్ ఎవ్రీ ఇయర్ వి ఆర్ సెలబ్రేటింగ్. మీకు మనకందరికీ తెలిసిందే, ఈ ఉగాది ఫెస్టివల్ లో అన్ని తీపి చేదు కలయిక, సుఖ సంతోషాల కలయికే ఈ పండుగ యొక్క ముఖ్య ఉద్దేశము. సో ఉగాది పచ్చడి లాగే మన జీవితం కూడా అనేక రుచులు. సో విశ్రమమే ప్రతి రుచిని ఆనందంగా స్వీకరించాలి, సుఖ సంతోషాలను కూడా అందరూ పంచుకోవాలి. ఎవ్రీ ఇయర్ వి ఆర్ సెలబ్రేటింగ్. సో today we discuss about magnetic effect of electric current. Magnetic effect of electric current. Generally, you know magnet. What is the property of the magnet? If you take a magnet, magnet attract the small metals like iron, nickel, cobalt. So if you take a magnet, so generally magnet it will attract some metals like some metal pieces attracted by the magnet is iron fillings. So iron fillings are nickel or cobalt attracted. Like fillings nickel, so cobalt, these are the metals attracted by the magnet. If you take a magnet, any magnet it have two poles, north and south pole. Any magnet it have north and south pole. So generally first who discovered the magnet? Generally magnet, one shipper person, he went to the ship, so when he put the stick, so when he went to the mountains, so this metal attracted by one big stone, so that is only lodestone first. So natural magnet, that is the natural magnet. So what is the natural magnet? Means lodestone. Natural magnet is lodestone. Lodestone. So this first discovered, this magnet naturally available, so it will attract the metals like iron, cobalt, nickel. So nowadays we are preparing so many magnets, artificial magnet, different shape of magnet, ring magnet, bar magnet, horseshoe magnet. So different shapes. Which shape we require, that shape we are preparing magnet. So what is the use of the magnet? Generally, these magnets we are using all electrical appliances. In computer also we are using, in mobile also we are using magnet, even TV also we are using magnet. This magnet receiving the signals, so attract the signals. So that purpose all electrical appliances we are using this magnet. So if we take a magnet, what is the property of the magnet? Magnetism. What is magnetism? Attraction property. So the attraction property of the magnet only called magnetism we are saying. So if you take a magnet, generally this is a bar magnet. Bar magnet, if you take any magnet, it have two poles. So north and south pole. One pole is north, one pole is south pole. So now, so what is this attraction property? More so what is magnetic field? What is the magnetic field? Magnetic field. So magnetic field means here. So if we take a magnet, around the magnet, this is a magnet. This is a magnet. So magnet it has how many poles? Two poles. One is north and one is south pole. North and south pole. The area around the magnet. So these are suppose around the magnet some area. The region around the magnet, how much area this effect, magnet effect is present. This is the field. So this attraction property of the magnet, some area distributed. This area is called magnetic field. What we are calling magnetic field. Magnetic field we are saying magnetic field. So the region surrounding magnet, the effect of the magnet, how much area distributed, that area is called magnetic field. Magnetic field is a vector quantity. So vector quantity, we have both magnitude and direction, vector quantity. So we make the magnet is different methods we are using. So one of the method is single touch method, so double touch method, and magnetic induction. So electromagnet. These are the methods we are using to make a magnet, artificial magnet, single touch method. Generally, how we make the magnet? So suppose you take a one soft iron metal. After you take a magnet, you just rub the magnet on this. So this is a soft iron. This is a soft iron metal. Soft iron. This is a soft iron. So just you take a magnet. So this is a north pole. Just you rub it. So after 10 times after rubbing, this soft iron also become a magnet. So these are one of the method to make a magnet, single touch method. Double touch method means we take the two magnets, we keep the two magnets in middle of this soft iron, just you rub it. So just you rub it. After some time, this soft iron also become a magnet. The soft iron also become a magnet. These are the one method to make a magnet. So next, magnetic induction. What is your magnetic induction? Magnetic induction. So magnetic induction. So magnetic induction means simple here. This is a magnetic field. So around the magnet, how much area it is spread? That is magnetic field. So we take a soft iron. This is a soft iron metal. Is a soft iron. Soft iron. So we place the soft iron. So when we place in field, so what will happen? Some field lines are passing through this iron. Some magnetic field lines are passing through this iron. After 10 minutes or after 15 minutes, when we take out this soft iron, it is also become a magnet. This method of making a magnet, this method is called magnetic induction. Due to this magnet, so this soft iron also become a magnet. This method is called magnetic induction. So here when we see this is a field, if you put the any metals in this area only, it will attract. So out of the magnetic field, the metals do not attracted by the magnet. Metals do not attracted by the magnet. So this one we are taking up. Now we go to this. When we bring the two magnets, so what will happen? So any magnet have two poles. So two poles, one is the north pole, one is the south pole. This is the magnet. If we take magnet, so the attraction property of the magnet, north pole, south pole, the attraction property more at the poles, is a south pole. This is a south pole. So these are north pole we are taking, north pole. So N pole, north pole, these are south pole. So magnetic, so the middle of the magnetic field is less. Middle of the magnetic field is less. So one of the properties is directionality. So two magnets. When we bring the two magnets, this is one magnet of south pole, this is the north pole. Another magnet of south pole and north pole. When we bring the two magnets, two poles, same poles. So same poles are repulsing to each other. So repulse to each other. So when we bring the two magnets, same poles. So the poles, same poles, like poles. We are saying like poles. So like poles means same poles. Same poles are repulsing to each other. So when we bring the different poles, so how it will be attracted? So same poles when we bring the same poles, so so when we take the one magnets, so when we bring the two magnets, one is of north pole and another one is of south pole. So one is north pole, any magnet have two poles. So south and these are the unlike poles, different poles. So when we bring the unlike poles, both are attracting. Unlike poles, so attract to each other. to each other. Attract to each other. So unlike poles means different poles. Unlike poles means different poles are attracting. This is about a magnet. But what is the magnetic effect of electric current? So we know only magnet only attracting. But one scientist, so what is that scientist means? So after one scientist can be explain the relation between the magnetic, yes. So magnetic effect and electric current. So here one more important property we are taking, directionality property. Magnetic have a directionality property. Directionality property. So if you take a magnet, just you suspend the magnet. So with the help of the thread, you suspend the magnet with the help of the thread. This magnet always shows the north and south direction only. So magnet, just you take one thread, you fix the one thread in one position. We hang the magnet. This magnet it shows the towards it comes to the rest in the direction of earth and north south direction. Magnetic always shows the north and south direction. North and south direction. That's why we are using this magnet. Navigation people they are using to identify so this designation of position of where we should go to that place. So they are finding they are using navigation people. So now, so magnetic field lines. So when we take the magnetic field lines, so these are now what are the magnetic field lines we are taking? So magnetic field lines. So now we should take. If we take a magnet, so magnetic field lines, magnetic field lines, magnetic field lines we are taking. So if we take a magnet, so this is a magnet we should take. So this is a magnet. So how the magnetic field lines are forming north and south pole. So magnetic field lines starting from the north, moving towards the south pole is the direction. Starting from the north, moving towards the south. So the magnetic field lines are starting from the north, moving towards the south direction. These are magnetic field lines. So these are magnetic field lines here also. North pole and south pole, magnetic field lines are forming. North to south, north to south. What is the direction of field lines? Means north starting rising. Or here from north moving towards the south direction. Here also magnetic field lines are forming. These are magnetic field lines so ending at south pole. Starting at north pole, ending at starting at north pole, ending at south pole. So magnetic field strength is more at pole. Strength is more. Strength of field. Strength of field is more. Strength of field is more at the poles. At north pole, at south pole, strength is more attractive. If you place the iron filling, so more attractive at north and south pole only. So strength is less in middle. So middle of the magnetic field strength is less. So what are the properties of the magnetic field lines? So first point, magnetic field lines starting from north, moving towards the south direction. Second point, magnetic field lines is a closed loops. Magnetic field lines is a closed loop. So closed loops. Magnetic field lines starting from north to closed loop. Okay, is a closed loop. So again, third point, magnetic field lines do not intersect. Magnetic field lines do not intersect. Intersect means do not meet. These are magnetic field lines. How we find the direction of magnetic field? We draw one tangent. At that point. That tangent line only it giving the direction of magnetic field. This is how the magnetic lines are forming around a magnet and magnetic field lines properties. Now we go to the effect of electric current. So this is about magnet. But how we can make a magnet? So different methods we are using, single touch method, double touch method, electromagnetic method. So scientists Oil-State scientist first. Oil-State scientist. Oil-State. So oil-State scientist. So he experiment. What is oil-State experiment means? Here before scientists they don't know what is the relation between the current and magnetic field. So one scientist, oil-State scientist, he explained the relation between the electric current and magnetic field. Means when the current passing through the wire, current wire, so around the wire magnetic field is producing. So first he explained by oil-State scientist. These are also called oil-State experiment. So what he explained means after so many instruments discovered after oil-State, so still nowadays we are using electric bulb. So based on the oil-State experiment only we prepared. So electric motor, generator. So these are all electrical appliances. So which are depending on the electromagnets. So many electromagnets we are using to lift the big weight. So this is also we are using nowadays because of oil-State experiment only. What is oil-State experiment means? Here you took one cardboard. You took one cardboard. So these are cardboard. So after you took the two V sticks, V-shaped sticks or Y-shaped sticks fixed at this point. Here also fixed at make a hole. So fixed at this point. So first of all you take one cardboard. You fix the V-shaped sticks and you make two holes at the end of the cardboard. Fixing after you took one 24 gauge copper wire. He arranging along these sticks. So along these sticks he arrange. Along these sticks he arrange. So he switch also he connected. So he connect the battery also positive and negative terminal. Here also positive and negative terminal connected. So this after. So when switch on, what will happen? When switch on, current passing through this wire. When switch on, what will happen? Current passing through this wire. After it took one magnetic compass. What is the use of the magnetic compass? We find the magnetic field with the help of the magnetic compass. Here magnetic compass like it is available. So this is the magnetic compass we should take. So this is the magnetic compass. So here we should take magnetic compass. With the help of the magnetic compass, so magnetic compass, so magnetic compass. So with the help of the magnetic compass, we find the magnetic field is present or not, which direction magnetic field we find with the help of the magnetic compass. When switch on, current passing through this wire, he observed it took a magnetic compass. He placed the below the wire. So below the wire we place the magnetic compass. So it will deflect. This magnetic compass needle deflecting. So why it is deflecting? Because of magnetic field. Because of the magnetic field. When the current passing through that wire, around the wire magnetic field is producing. So means he explained the relation between electric current and magnetic. First, which side is explained means oil-State. So these are oil-State experiment. There are so many instruments discovered already. I told you. This is about oil-State experiment. So here magnetic field lines, how it is forming? We take a wire. So around the wire magnetic field lines are forming circular path. Around the wire magnetic field lines are forming circular path. So how it is wire? So magnetic field lines are also forming around the wire circular path. So based on the direction of current we are explaining. So when the current is moving, so into the page, out of the page we are taking. When the current is moving into the page, so into the page means magnetic field lines. So into the page means magnetic field lines are clockwise direction. Into the page is into the page is into the page we are taking. So magnetic field lines clockwise direction. Clockwise magnetic field lines clockwise direction. So when out of the page, so out of the current direction. So out of the page, magnetic field lines are forming anti-clockwise direction. Anti-clockwise direction. So this is the oil-State experiment. First he explained relation between the current and magnetic field. So after that, so many discovered. This is a small topic. We discovered magnetic field, magnet properties, and Archer experiment. Thank you for everyone watching my video. Please subscribe and share, like my videos. And thank you one more again. Ugadi Shubhakankshalu. అందరికీ ఉగాది శుభాకాంక్షలు తెలియజేస్తున్నాను. సో అందరూ